quadratic equation if, when the number is substituted for the variable, the equation becomes a true statement. For quadratic equations, there are at most two real roots. There are several ways by which roots of a quadratic equation can be found. For our learning target, at the end of this learning session, you should be able to solve quadratic equations by extracting square roots, factoring, completing the square, and using the quadratic formula. Now, let's get started. Let's have a recall on algebraic techniques involving polynomials to fully understand the procedures in solving quadratic equations through Activity 1. Am I standard? Determine if the given equation is quadratic. If yes, write it in standard form, then identify the values of A, B, and C. For number 1, x is equal to 2x squared plus 5. You have 5 seconds to answer that. Your time starts now. Time up. The correct answer is quadratic. Very good. To determine the standard form of x is equal to 2x squared plus 5, place all the terms into the left side and the right side is just 0. Applying the properties of equality, we have 2x squared minus x plus 5 is equal to 0. The values of a, b, and c are as follows. A is equal to 2, b is equal to negative 1, c is equal to 5. The other way to write the given equation in standard form is negative 2x squared plus x minus 5 is equal to 0. Here, the values of a, b, and c are as follows. A is equal to negative 2, b is equal to 1, c is equal to negative 5. So, the original equation x is equal to 2x squared plus 5 can be written into two ways. We have 2x squared minus x plus 5 is equal to 0, or negative 2x squared plus x minus 5 is equal to 0. The two equations are considered equivalent quadratic equations.
Number 2. X squared plus 4x minus 5 is equal to 0. Have 5 seconds to answer that. Your time starts now. Time out. The correct answer is quadratic. Very good. You got the correct answer. And its standard form is x squared plus 4x minus 5 is equal to 0. And the values of a, b, and c are as follows. A is equal to 1, b is equal to 4, c is equal to negative 5. Or, its equivalent quadratic equation is negative x squared minus 4x plus 5 is equal to 0. The values of a, b, and c are as follows. A is equal to negative 1, b is equal to negative 4, c is equal to 5.
For number 3, 9x is equal to x squared. You have 5 seconds to answer that. Your time starts now. Time up. The correct answer is quadratic. Very good. And its standard form is x squared minus 9x is equal to 0. The values of a, b, and c are as follows. A is equal to 1, b is equal to negative 9, c is equal to 0. And its equivalent quadratic equation is negative x squared plus 9x is equal to 0. The values of a, b, and c are a is equal to negative 1, b is equal to 9, c is equal to 0. For number 4, we have y squared plus y plus 5 is equal to 0. You have 5 seconds to answer that. Your time starts now. Time up. The correct answer is quadratic. Very good. And the values of a, b, and c are as follows. A is equal to 1, b is equal to 1, and c is equal to 5. And its equivalent equations is negative y squared minus y minus 5 is equal to 0. The values of a, b, and c are as follows. A is equal to negative 1, b is equal to negative 1, c is equal to negative 5. For item number 5, we have 5x squared minus 7x is equal to 0. You have 5 seconds to answer that. Your time starts now. The correct answer is quadratic. Very good. You got the correct answer. The standard form is 5x squared minus 7x is equal to 0. And the values of a, b, and c are as follows. A is equal to 5, b is equal to negative 7, c is equal to 0. And its equivalent equation is negative 5x squared plus 7x is equal to 0. The values of a, b, and c are a is equal to negative 5, b is equal to 7, and c is equal to 0. For number 6, we have 4 minus 2x plus 3x squared is equal to 0. You have 5 seconds to answer that. Your time starts now. Time up. The correct answer is quadratic. Very good. And the standard form is 3x squared minus 2x plus 4 is equal to 0. Here, the values of a, b, and c are as follows. A is equal to 3, b is equal to negative 2, c is equal to 4. And its equivalent equation is negative 3x squared plus 2x minus 4 is equal to 0. The values of a, b, and c are as follows. A is equal to negative 3, b is equal to 2, c is equal to negative 4. For number 7, we have x times x plus 5 minus 2x is equal to 0. You have 5 seconds to answer that. Your time starts now. Time up. The correct answer is quadratic. Very good. So the standard form of that is x squared plus 3x is equal to 0. The values of a, b, and c are a is equal to 1, b is equal to 3, c is equal to 0. And its equivalent equation is negative x squared minus 3x is equal to 0. Here, the values of a, b, and c are as follows. A is equal to negative 1, b is equal to negative 3, c is equal to 0. For number 8, we have x squared minus 2x times x minus 2 plus 5 is equal to 0. You have 5 seconds to answer that. Your time starts now. Time up. The correct answer is quadratic. Very good. You got the correct answer. And its standard form is negative x squared plus 4x plus 5 is equal to 0. And the values of the variable a, b, and c are a is equal to negative 1, b is equal to 4, c is equal to 5. And its equivalent equation is x squared minus 4x minus 5 is equal to 0. Here, the values of a, b, and c are as follows. A is equal to 1, b is equal to negative 4, c is equal to negative 5. For number 9, we have 2x plus 8 is equal to negative x squared. You have 5 seconds to answer that. Your time starts now. The correct answer is quadratic. Very good. You got the correct answer. Its standard form is x squared plus 2x plus 8 is equal to 0. The values of a, b, and c are as follows. A is equal to 1, b is equal to 2, and c is equal to 8. And its equivalent equation is negative x squared minus 2x minus 8 is equal to 0. The values of a, b, and c are a is equal to negative 1, b is equal to negative 2, c is equal to negative 8. Now, for the last item, we have 2x minus 5 times x plus 3 is equal to x times x minus 4. You have 5 seconds to answer that. Your time starts now. The correct answer is quadratic. Very good. You got the correct answer. And its standard form is x squared minus x plus 15 is equal to 0. The values of a, b, and c are as follows. A is equal to 1, b is equal to negative 1, c is equal to 15. And its equivalent equation is negative x squared plus x minus 15 is equal to 0. The values of a, b, and c are as follows. A is equal to negative 1, b is equal to 1, c is equal to negative 15.
How was your activity you have just done? Was it easy for you to write quadratic equations in standard form? It was easy for sure.
As you go through this session, think of this important question. How are quadratic equations used in solving real-life problems and in making decisions? Let's consider this problem. A square piece of cardboard is to be used to form a box without a top by cutting off squares 3 cm on a side from each corner and then folding up the sides. The volume of the box must be 300 cubic centimeter. 1. Draw a diagram to illustrate the given situation. 2. How are you going to represent the length of the side of a square piece cardboard? How about its volume? 3. What will be the dimension of the box with a square base? 4. How will you find the length of each side of the box?
Addition, subtraction, multiplication, and division of real numbers are the key to your success in solving linear and quadratic equations. In solving quadratic equation, you must know how to get the square root of a number, how to factor expressions, and how to apply properties of real numbers. The different methods of solving quadratic equations are extracting the square root, factoring, completing the square, and using the quadratic formula. The solution of a quadratic equation is called roots of the equation. A quadratic equation has at most two roots.
Now, going back to the problem, let x be the length of each side of the cardboard. When a 3 cm square is cut off from each corner and then fold up, a box with a square base x minus 6 cm on its side, and a height of 3 cm will be formed. And the width of the box is x minus 6 cm. From the problem, the volume is 300 cubic centimeter. And the height of the box is 3 centimeter. In computing the volume of the box, we use the formula. Volume is equal to the length times the width times the height. The volume is 300 cubic centimeter is equal to the length is x minus 6, the width is x minus 6 times the height, which is 3 centimeter. Simplify the equation, we have 3 times x minus 6 raised to 2 is equal to 300. By using the multiplication property of equality, multiply both sides by 1/3. Then simplify. 1/3 times 3 times x minus 6 raised to 2. We can cancel your 3 and 3. That is equal to the quantity x minus 6 raised to 2 is equal to 300 times 1/3 is equal to 100. Simplify the given expression by extracting the square root both sides. We have the square root of x minus 6 raised to 2 is equal to the square root of 100. Then, the square root of the quantity x minus 6 raised to 2 is equal to x minus 6 is equal to square root of 100 is positive negative 10. Then, to get the values of x, we need to simplify this expression. So we have x minus 6 is equal to 10. Then, by applying the addition property of equality, add both sides by positive 6. We have x is equal to 10 plus 6. Simplify it, we have 10 plus 6 is 16. Then, we have the next equation, x minus 6 is equal to negative 10. By applying the addition property of equality, add both sides by 6. We have x is equal to negative 10 plus 6. Simplify the expression, negative 10 plus 6 is equal to negative 4. But reject this value. Therefore, the square cardboard must be 16 centimeter on each side. The method of solving quadratic equation x raised to 2 is equal to k is what we call extracting square roots. The square root method is used in solving incomplete quadratic equations of the form x raised to 2 is equal to c, when c is a non-negative number. Quadratic equations that can be transformed in the form x raised to 2 is equal to k can be solved by applying the properties. Number 1, if k is greater than 0, then x squared is equal to k has two real solutions or roots. That is, x is equal to positive or negative square root of k. Number 2, if k is equal to 0, then x raised to 2 is equal to k, has one real solution or root. That is, x is equal to 0. Number 3, if k is less than 0, then x raised to 2 is equal to k, has no real solutions or root. The square root property of real numbers states that if u squared is equal to d, then u is equal to the square root of d, or u is equal to the negative square root of d, for d is greater than or equal to 0. A shorter way of writing the two solutions, u is equal to the square root of d and u is equal to negative square root of d, is to write using double sign notation. That is, u is equal to positive negative square root of d. Now, let's consider this example. Find the roots of 4x squared minus 81 is equal to 0 by extracting the square roots. First, we are going to write 4x squared minus 81 is equal to 0 in the form x squared is equal to k. That is, by applying addition property of equality, add both sides by 81. Then, simplify. We can cancel your negative 81 plus 81 because that is equal to 0. Then copy 4x squared is equal to 0 plus 81 is equal to 81. Then, applying the multiplication property of equality, multiply both sides by 1/4. 1/4 times 4x raised to 2 is equal to x raised to 2 is equal to 81 times 1/4 is equal to 81 all over 4. Then, extract the square root both sides. We have square root of x squared is equal to square root of 81 all over 4. Then, simplify. Square root of x squared is x is equal to the square root of a number consists of two, a positive and negative. Square root of 81 is 9. All over square root of 4 is 2. Then, let's find out whether positive, negative 9 all over 2 is really the roots of 4x squared minus 81 by checking against the original equation. 4x is equal to 9 all over 2. The original equation is 4x squared minus 81 is equal to 0. Substitute the value of x in the original equation. We have 4 times the value of x, which is 9 all over 2 raised to 2 minus 81 is equal to 0. Then simplify. 4 times the square of 9 all over 2 is 81 all over 4 minus 81 is equal to 0. Then simplify. 4 times 81 divided by 4, or we can just simply cancel 4 and 4 here because they are equal to 1. Then the answer is 81 minus 81 is equal to 0. Then simplify 81 minus 81 is equal to 0. Is equal to 0. Then it is a true equation. Therefore, 9 all over 2 is a root of 4x squared minus 81 is equal to 0. Now, 4x is equal to negative 9 all over 2. The original equation is 4x squared minus 81 is equal to 0. Substitute the value of the variable in the original equation. We have 4 times the value of x is negative 9 all over 2 square minus 81 is equal to 0. Then simplify. 4 times the square of negative 9 all over 2 is positive 81 all over 4 minus 81 is equal to 0. Simplify. 4 times 81 all over 4 is 81 minus 81 is equal to 0. Simplify. 81 minus 81 is equal to 0 is equal to 0. And it is a true equation. Therefore, negative 9 all over 2 is a solution of 4x squared minus 81 is equal to 0. Therefore, the roots of 4x squared minus 81 is equal to 0 are positive and negative 9 all over 2. Some quadratic equations can be solved easily by factoring. Factoring is a method used to solve a quadratic equation in the form ax squared plus bx plus c is equal to 0, or ax squared plus bx is equal to 0. To solve such quadratic equations, the following procedure can be followed. Number 1, transform the quadratic equation into standard form if necessary. Number 2, factor the quadratic expression. Number 3, apply the zero product property by setting each factor of the quadratic expression equal to 0. Zero product property states that if a and b are real numbers and a times b is equal to 0, then a is equal to 0 or b is equal to 0. This is also true for 3 or more factors. For any factor equal to 0, the product is 0. Let's have an example. Find the roots of x times the quantity 3x minus 18 is equal to 21 by factoring. The given is x times 3x minus 18 is equal to 21. Then simplify. X times 3x is equal to 3x squared. X times negative 18 is negative 18x is equal to 21. Then, applying the addition property of equality, add both sides by negative 21. That is 3x squared minus 18x plus negative 21. Then, simplify. Copy 3x squared minus 18x. Positive times negative 21 is negative 21 is equal to 0 because 21 plus negative 21 is 0. Then, as you can observe, the numerical coefficient of the quadratic term, the linear term, and the constant term is divisible by 3. So in order for us to easily factor that, then we are going to divide by 3. Then 3x squared divided by 3 is x squared. Negative 18x divided by 3 is negative 6x. Negative 21 divided by 3 is negative 7 is equal to 0. Then, factor x squared minus 6x minus 7 is equal to 0. Factor the quadratic term x squared is x and x. Factor of negative 7, in which if you are going to add, it will give you negative 6. That is positive 1 and negative 7. Then, applying the zero product property, we have to equate the factors into 0. That is, x plus 1 is equal to 0 and x minus 7 is equal to 0. Then, simplify. By addition property of equality, add both sides by negative 1. That is, x plus 1 plus negative 1 is equal to 0 plus negative 1. Then simplify, x sub 1 now is equal to 0 plus negative 1 is negative 1. For x minus 7 is equal to 0, by addition property of equality, add both sides by positive 7. Then simplify, where x sub 2 is equal to 0 plus 7 is 7. Then to check whether negative 1 and 7 are the solution of x times 3x minus 18 is equal to 21, let's substitute it into the original equation. For x is equal to negative 1, the original equation is x times 3x minus 18 is equal to 21. Substitute the value of your x, which is negative 1, times the value of x is negative 1 minus 18 is equal to 21. Then simplify. Copy negative 1 and 3 times negative 1 is negative 3 minus 18 is equal to 21. Then simplify. Copy negative 1, negative 3 minus 18 is negative 21 is equal to 21. Negative 1 times negative 21 is equal to positive 21 is equal to 21. The left side and the right side are equal, then we have a true equation. So, x is equal to negative 1 is a solution of x times 3x minus 18 is equal to 21. Now, let's find out 7, whether it is a solution or not in the given equation. So, the original equation is x times 3x minus 18 is equal to 21. Substitute the value of x, which is 7, times 3. Substitute the value of x again, which is 7, minus 18 is equal to 21. Then simplify. Copy 7. 3 times 7 is 21 minus 18 is equal to 21. Then simplify. Copy 7. 21 minus 18 is 3 is equal to 21. 7 times 3 is 21 is equal to 21. The left side of the given equation is equal to the right side of the equation. Then we have a true equation. Then 7 is a solution of the given equation. Therefore, the roots of x times 3x minus 18 is equal to 21 are negative 1 and 7. Another way of solving quadratic equations is by completing this square. Let's have an example. Find the roots of 2x squared minus 5x plus 1 is equal to 0 using the completing this square. The given equation is 2x squared minus 5x plus 1 is equal to 0. We need to divide both sides of the equation by 2 in order for the numerical coefficient of the quadratic term be equal to 1. So that is divided by 2. That is 2x squared divided by 2 is x squared. Negative 5x divided by 2 is negative 5 all over 2x. 1 divided by 2 is positive 1 half. Is equal to 0 divided by 2 is 0. Then simplify. All variables must be at the left side. All constant must be at the right side. So by applying addition property of equality, add both sides by negative 1 half. Then simplify. We can cancel 1 half and negative 1 half because that is 0. Then we can copy x squared minus 5 all over 2x is equal to negative 1 half. Then we will make x squared minus 5 all over x a perfect square trinomial. So we just simply add both sides by n. Then in determining the value of n that will make this expression perfect square trinomial, we are going to use this formula. N is equal to b all over 2 raised to 2. So from the given expression, x squared minus 5 all over 2x is equal to negative 1 half. The value of b is the numerical coefficient of the linear term, which is equal to negative 5 all over 2. By using the formula, n is equal to the quantity b all over 2 raised to 2. Substitute the value of b, which is negative 5 halves all over 2 raised to 2. Simplifying that complex fraction, we need to copy the numerator, which is negative 5 halves, and multiply the reciprocal of the denominator, which is 1 half raised to 2. Then simplify. Negative 5 times 1 is negative 5. 2 times 2 is 4. That is equal to negative 5 all over 4 raised to 2. Then simplify. Negative 5 raised to 2 is 25. 4 raised to 2 is 16. Then we have 25 all over 16. Then that is the value of n that will make x squared minus 5 all over 2x a perfect trinomial. Then we are going to substitute the value of n that will make the expression a perfect square trinomial, which is 25 all over 16. Then simplify the right side of the given equation. So copy the left side, which is x squared minus 5 all over 2x plus 25 all over 16 is equal to the LCD of negative 1 half plus 25 all over 16 is 16. 16 divided by 2 is 8 times negative 1 is negative 8. 16 divided by 16 is 1 times 25 is positive 25. Then simplify. Copy the left side of the given equation is equal to negative 8 plus 25 is 17 all over 16. Then the factor of x squared minus 5 all over 2x plus 25 all over 16. Since this is a perfect square trinomial, then the factor is a square of the binomial. Square root of x squared is x. Square root of 25 all over 16 is 5 all over 4. Then the factor of this is the quantity x minus 5 all over 4 squared is equal to 17 all over 16. Then, solve the resulting quadratic equation by extracting the square root both sides. That is, square root of the quantity x minus 5 all over 4 raised to 2 is equal to the square root of 17 all over 16. The square root of the quantity x minus 5 all over 4 raised to 2 is x minus 5 all over 4. Then take the square root of this. We have positive negative square root of 17 all over square root of 16 is 4. Then all constant must be at the right side. Then simplify, applying the addition property of equality. Add both sides by 5 all over 4. That is, we can cancel your negative 5 all over 4 plus 5 all over 4 because that is equal to 0. X now is equal to positive negative square root of 17 all over 4 plus 5 all over 4. So, x sub 1 is equal to square root of 17 all over 4 plus 5 all over 4, or we can write that as 5 plus square root of 17 all over 4, and our x sub 2 is negative square root of 17 all over 4 plus 5 all over 4, or 5 minus square root of 17 all over 4.
Now, let's check whether the computed value of x is the solution of the equation. For x is equal to 5 plus square root of 17 all over 4, the original equation is 2x squared minus 5x plus 1 is equal to 0. Then substitute the value of the variable x into the original equation. That is 2 times the value of x, which is 5 plus square root of 17 all over 4 raised to 2, minus 5 times the value of x, which is 5 plus square root of 17 all over 4 plus 1 is equal to 0. Then simplify. Copy 2, square the binomial, that is equal to square of the first term, which is 5, that is equal to 25. Then, to get the middle term, twice the product of the first term and the second term. That is 2 times 5, 10, times square root of 17 is positive 10, square root of 17. To get the last term, square the second term of the binomial, which is square of the square root of 17 is positive 17, all over square of the denominator, which is 4 square is 16. Then simplify the next expression. Negative 5 times 5 is negative 25 all over 4. Negative 5 times positive square root of 17 is negative square root of 17 all over 4, plus 1 is equal to 0. Then simplify. Since 25 plus 17 are similar, so we can just combine that. That is equal to 42. And copy plus 10 is square root of 17. 2 and 16 are divisible by 2. That is equal to 8. Minus 25 all over 4 minus 5 square root of 17 all over 4 plus 1 is equal to 0. Simplify. 42 all over 8, that is equal to 21 all over 4, plus 10 all over 8, reduce that one to lowest term, that is 5 all over 4 times the square root of 17, minus 25 all over 4, minus 5 square root of 17 all over 4, plus 1 is equal to 0. Simplify it further, we can subtract 5 square root of 17 all over 4 minus 5 square root of 17 all over 4, because they are similar, that is equal to 0. Then simplify 21 all over 4 minus 25 all over 4 is negative 4 all over 4. That is equal to negative 1. Plus 1 is 0, is equal to 0. The left side and the right side of the given equation are equal. Then we have a true equation. Therefore, x is equal to 5 plus the square root of 17 all over 4 is a solution of the quadratic equation. For the second value of x, we have x is equal to 5 minus the square root of 17 all over 4. The original equation is 2x squared minus 5x plus 1 is equal to 0. Again, substitute the value of the variable into the original equation. That is 2 times the value of x is 5 minus square root of 17 all over 4 square, minus 5 times the value of x, which is 5 minus square root of 17 all over 4 plus 1 is equal to 0. And simplify. Copy 2, square the binomial. Applying the rule, we have square of 5, which is equal to 25. Then to get the second term, twice the product of the first term and the second term. That is 2 times 5 is 10 times negative square root of 17 is negative 10 square root of 17. Then to get the last term, square the second term of the binomial. That is square of negative square root of 17 is positive 17. Then square the denominator, which is 4 square, that is 16. Then simplify. Negative 5 times 5 all over 4 is negative 25 all over 4. Negative 5 times negative square root of 17 all over 4 is positive 5 square root of 17 all over 4 plus 1 is equal to 0. Then simplify. 2 and 16 are divisible by 2, so that is equal to 8. Then simplify 25 plus 17, that is equal to 42 minus 10 square root of 17 minus 25 all over 4 plus 5 square root of 17 all over 4 plus 1 is equal to 0. Then simplify. Reduce 42 all over 8 into lowest term, that is equal to 21 all over 4, and reduce 10 square root of 17 all over 8, that is equal to negative 5 square root of 17 all over 4 minus 25 all over 4 plus 5 square root of 17 all over 4 plus 1 is equal to 0. We can cancel negative 5 square root of 17 all over 4 and 5 square root of 17 all over 4 because they are opposite, and that is equal to 0. Then simplify. 21 all over 4 minus 25 all over 4 is negative 1 plus 1 is equal to 0, is equal to 0. As you can observe, the left and the right side of the given equation are equal, and we have a true equation. That means that the value of x, which is equal to 5 minus the square root of 17 all over 4, is a solution of the quadratic equation. We can say that the roots of 2x squared minus 5x plus 1 is equal to 0 are 5 plus minus the square root of 17 all over 4. Another way in solving the roots of a quadratic equation is by using the quadratic formula. To solve any quadratic equation, ax squared plus bx plus c is equal to 0, using the quadratic formula, determine the values of a, b, and c, then substitute these in the equation. X is equal to negative b plus minus square root of b squared minus 4ac all over 2a. Simplify the result if possible, then check the solutions obtained against the original equation. Let's have an example. Find the roots of 4x squared plus 12x plus 9 is equal to 0 using quadratic formula. First, see to it that the quadratic equation is in the standard form and identify the values of a, b, and c. The values of the variable a, b, and c here are as follows. A is equal to 4, b is equal to 12, and c is equal to 9. Then use the quadratic formula in computing the roots of the quadratic equation, which is x is equal to negative b plus minus the square root of b squared minus 4ac all over 2a. Then substitute the values of the variable. The value of b is 12 plus minus the square root of the value of b, which is 12 raised to 2, minus 4 times the value of a, which is 4, times the value of c, which is 9, all over 2 times the value of a, which is 4. Then simplify the numerical expression. We have negative 12 plus and minus the square root of, simplify, square of 12 is 144, negative 4 times 4 times 9 is equal to negative 144. 2 times 4 is equal to 8. Then simplify, that is negative 12 plus and minus square root of 144 minus 144 is 0. Square root of that is 0 all over 8. Then simplify, we have x is equal to negative 12 all over 8. Then reduce that one to lowest term. X is equal to negative 3 all over 2 because they are divisible by 4. Let's check whether the value of x, which is negative 3 all over 2, is a solution of 4x squared plus 12x plus 9 is equal to 0. So using the original equation, we have 4x squared plus 12x plus 9 is equal to 0. Substitute the computed value of x, that is 4 times the value of x, which is negative 3 halves squared, plus 12 times the value of x, which is negative 3 halves, plus 9 is equal to 0. Then simplify, copy 4, square negative 3 halves is equal to 9 all over 4. Square of 3 is 9, square of 2 is 4, square of negative is positive. Then simplify, that is 12 times negative 3 divided by 2, that is negative 18, plus 9 is equal to 0. Then simplify, that is 4 times 9 all over 4 is 9, negative 18 plus 9 is negative 9 is equal to 0. Then simplify, 9 minus 9 is 0 is equal to 0. The left side and the right side of the given equations are equal, so we have a true equation, meaning that negative 3 halves is a solution of 4x squared plus 12x plus 9 is equal to 0. Hence, the solution of 4x squared plus 12x plus 9 is equal to 0 is negative 3 halves.